Chapter 5. The wonder world to be created by electricity. Two tremendous leaps were made in the succeeding 40 years. One was when Franklin demonstrated the identity between the gentle soul of amber and the awe-inspiring belt of Jupiter. The other, when Galvani and Volta brought out the contact and chemical battery from which the magic fluid could be drawn in unlimited quantities. The succeeding 40 years bore still greater fruit. Oersted made a significant advance in deflecting a magnetic needle by an electric current. Arago produced the electromagnet, Seebeck the thermopile, and in 1831, as the crowning achievement of all, Faraday announced that he had obtained electricity from a magnet, thus discovering the principle of that wonderful engine, the dynamo, and inaugurating a new era both in scientific research and practical application. From that time on, inventions of inestimable value have followed one another at a bewildering rate. The telegraph, telephone, phonograph, and incandescent lamp, the induction motor, oscillatory transformer, Röntgen ray, radium. Wireless and numerous other revolutionary advances have been made, and all conditions of existence 84 years which have since elapsed. The subtle agents dwelling in the living amber and lodestone have been transformed into cyclopean forces, turning the wheels of human progress with ever-increasing speed. This, in brief, is the fairy tale of electricity from Thales to the present day. The impossible has happened, the wildest dreams have been surpassed, and the astounded world is asking, what is coming next? Electrical possibilities in coal and iron. Many a would-be discoverer, failing in his efforts, has felt the regret to have been born at a time when everything has been already accomplished and nothing is left to be done. This erroneous impression that, as we are advancing, the possibilities of invention are being exhausted is not uncommon. In reality, it is just the opposite. Spencer has conveyed the right idea when he likens civilization to the sphere of light, which a lamp throws out in darkness. The brighter the lamp and the larger the sphere, the greater is its dark boundary. It is paradoxical yet true to say that the more we know, the more ignorant we become in the absolute sense, for it is only through enlightenment that we become conscious of our limitations. Precisely one of the most gratifying results of intellectual evolution is the continuous opening up of new and greater prospects. We are progressing at an amazing pace, but the truth is that even in fields most successfully exploited, the ground has only been broken. What has been so far done by electricity is nothing compared with what the future has in store. Not only this, but there are now innumerable things done in old-fashioned ways which are much inferior in economy, convenience, and many other respects to the new method. So great are the advantages of the latter that whenever an opportunity presents itself, the engineer advises his client to do it electrically. Consider, in illustration, one of the largest industries, that of coal. From this valuable mineral, we chiefly draw the sun's stored energy, which is required to meet our industrial and commercial needs. According to statistical records, the output in the United States during the past year was 480,000 tons. In perfect engines, this fuel would have been sufficient to develop 500 horsepower steadily for 1 year, but the squandering is so reckless that we do not get more than 5% of its heating value on the average. There is an appalling waste in mining, handling, transportation, store, and use of coal, which could be very much reduced through the adoption of a comprehensive electrical plan in all these operations. The market value of the yearly product would be easily doubled and an immense sum added to the revenues of the country. What is more, inferior grades, billions of tons of which are being thrown away, might be turned to profitable use. Similar considerations apply to natural gas and mineral oil, the annual loss of which amounts to hundreds of millions of dollars. In the very near future, such waste will be looked upon as criminal, and the introduction of the new methods will be forced upon the owners of such properties. Here, then, is an immense field for the use of electricity in many ways, vast industries which are bound to be revolutionized through its extensive application. To give another example, I may refer to the manufacture of iron and steel, which is carried on in this country on a scale truly colossal. During the last year, notwithstanding unfavorable business conditions, 31,000 tons of steel have been produced. It would lead too far to dwell on the possibilities of electrical improvements in the manufacturing processes themselves. And I will only indicate what is likely to be accomplished in using the waste gases from the coke ovens and blast furnaces to generate electricity for industrial purposes. Since in the production of pig iron, for every ton about 1 ton of coke is employed, the yearly consumption of coke may be put at 3100 tons. The combustion in the blast furnaces yields per minute 700 cubic feet of gas of a heating value of 110 BT units per cubic foot. Of this total, without making special provision, 400 cubic feet may be made available for power purposes. If all the heat energy of this gas could be transformed into mechanical effort, it would develop 10,389 horsepower. This result is impossible, but it is perfectly practicable to obtain 2,500 horsepower electrical energy at the terminals of the dynamos. In the manufacture of coke, approximately 9,400 cubic feet of gas are evolved per ton of coal. This gas is excellent for power purposes, having an average heating value of 600 BT units, but very little is now used in engines, largely because of their great cost and other imperfections. A ton of coke requires about 132 tons of American coal. Hence, the total coal consumption per annum on the above basis is nearly 4,100 tons, which give per minute 733 cubic feet of gas. Assuming the yield of surplus or rich gas to be 333 cubic feet, the balance of 400 cubic feet could be used in gas engines. The heat content would be theoretically sufficient to develop 660 horsepower, of which 500 horsepower could be obtained in the form of electric energy. I have devoted much thought to this industrial proposition and find that with new, efficient, extremely cheap and simple thermodynamic transformers, not less than 400 horsepower could be developed in electric generators by utilizing the heat of these gases, which, if not entirely wasted, are only in part and inefficiently employed. With systematic improvements and refinements, much better results could be secured and an annual revenue of $50 or more derived. The electrical energy could be advantageously used in the fixation of atmospheric nitrogen and production of fertilizers, for which there is an unlimited demand, and the manufacture of which is restricted here on account of the high cost of power. I expect confidently the practical realization of the project in the very near future and look to exceptionally rapid electrical development in this direction. Hydroelectric development water power offers great opportunities for novel electrical applications, particularly in the Department of Electrochemistry. The harness of waterfalls is the most economical method known for drawing energy from the sun. This is due to the fact that both water and electricity are incompressible. The net efficiency of the hydroelectric process can be as high as 85%. The initial outlay is generally great, but the cost of maintenance is small, and the convenience offered ideal. My alternating system is invariably employed, and so far about 70 horsepower have been developed. As generally used, we do not get more than 0.06 of a horsepower per ton of coal per year. This water energy is therefore equivalent to that obtainable from an annual supply of 120 tons of coal, which is about 25% of the total output in the United States. The estimate is conservative, and in view of the immense waste of coal, 50% may be a closer guess. We get better appreciation of the tremendous value of this power in our economic development when we remember that, unlike fuel, which demands a terrible sacrifice of human energy and is consumed, it is supplied without effort and destruction of material and equals the mechanical performance of 150 men, 1.5 times the entire population of this country. These figures are imposing. Nevertheless, we have only begun the exploitation of this vast national resource. There are two chief limitations at present, one in the availability of the energy, the other in its transmission to distance. The theoretical power of the falling water is enormous. If we assume for the rain clouds an average height of 15 feet and annual precipitation of 33 inches, the 24 horsepower per square mile is over 4,000. And for the whole area in the United States, more than 1,200 horsepower. As a matter of fact, the larger portion of the potential energy is used up in air friction. This, while disappointing to the economist, is a fortunate circumstance, for otherwise the drops would reach the ground with a speed of 800 feet per second, sufficient to raise blisters on our bodies, while hail would be positively deadly. Most of the water, which is available for power purposes, comes from a height of about 2,000 feet and represents over 1.5 billion horsepower. But we are only able to use an average fall of, say, 100 feet, which means that if all of the water power in this country were harnessed under the existing conditions, only 800 horsepower could be obtained. The next great achievement, electrical control of atmospheric moisture, but the time is very near when we shall have the precipitation of the moisture of the atmosphere under complete control. And then it will be possible to draw unlimited quantities of water from the oceans, develop any desired amount of energy, and completely transform the globe by irrigation and intensive farming. A greater achievement of man through the medium of electricity can hardly be imagined. The present limitations in the transmission of power to distance will be overcome in two ways: through the adoption of underground conductors insulated by power, and through the introduction of the wireless arc. The first plan I have advanced years ago. The underlying principle is to convey, through a tubular conductor, hydrogen at a very low temperature, freeze the surrounding material, and thus secure a perfect insulation by indirect use of electric energy. In this manner, the power derived from falls can be transmitted to distances of hundreds of miles with the highest economy, and at a small cost. This innovation is sure to greatly extend the fields of electrical application. As to the wireless method, we have now the means for economic transmission of energy in any desired amount, and to distances only limited by the dimensions of this planet. In view of assertions of some misinformed experts to the effect that in the wireless system, I have perfected the power of the transmitter is dissipated in all directions, I wish to be emphatic in my statement that such is not the case. The energy goes only to the place where it is needed, and to no other. When these advanced ideas are practically realized, we shall get the full benefit of water power, and it will become our chief dependence in the supply of electricity for domestic, public, and other uses in the arts of peace and war. Economy in light and power, electric propulsion. In the great departments of electric light and power, immense opportunities are offered through the introduction of all kinds of novel devices, which can be attached to the circuits at convenient hours. For the purpose of equalizing the loads and increasing the revenues from the plants, I have myself knowledge of a number of new appliances of this kind. The most important among them is probably an electrical ice machine, which obviates entirely the use of dangerous and otherwise objectionable chemicals. The new machine will also require absolutely no attention and will be extremely economical in operation, so that the refrigeration will be effected very cheaply and conveniently in every household. An interesting fountain, electrically operated, has been brought out, which is likely to be extensively introduced, and will afford an unusual and pleasing sight in squares, parks, hotels, and residences. Cooking devices for all domestic purpose are being provided, and there is great demand for practical designs and suggestions in this field. The same may be stated of electric signs and other attractive means of advertising which can be electrically operated. Some of the effects which it is possible to produce by electric currents are wonderful and lend themselves to exhibitions, and there is no doubt that much can be done in that direction. Theaters, public halls, and private dwellings are in need of a great many devices and instruments for convenience and offer ample opportunities to an ingenious and practical inventor. A vast and absolutely untouched field is the use of electricity for the propulsion of ships. The leading electrical company in this country has just equipped a large vessel with high-speed turbines and electric motors, and has achieved a signal success. Applications of this kind will multiply at a rapid rate, for the advantages of the electrical drive are now patent to everybody. In this connection, gyroscopic apparatus will probably play an important part, as its general adoption on vessels is sure to come. Very little has yet been done in the introduction of electrical drive in the various branches of industry and manufacture, and the prospects are unlimited. A few of the wonders to come books have already been written on the agricultural uses of electricity, but the fact is that hardly anything has been practically done. The beneficial effects of electricity of high tension have been unmistakably established, and a revolution will be brought about through the extensive adoption of agricultural electrical apparatus. The safeguarding of forests against fires, the destruction of microbes, insects, and rodents will, in due course, be accomplished by electrical means. In the near future, we shall see a great many new uses of electricity aiming at safety, particularly vessels at sea die off. We shall have electrical instruments for preventing collisions, and we shall even be able to disperse fogs by electric force and powerful and penetrative rays. I am hopeful that within the next few years, wireless plants will be installed for the purpose of illuminating the oceans. The project is perfectly feasible, and if carried out, will contribute more than any other provision to the safety of property and human lives at sea. The same plant could also produce stationary electrical waves and enable vessels to get at any time accurate bearings and other valuable practical data without resorting to the present means. It could also be used for time signaling and many other purposes of similar nature. Electrotherapy is another great field in which there are unlimited possibilities for electrical applications. High-frequency currents especially have a great future. The time will come when this form of electrical energy will be available in every private residence. I consider it quite possible that through their surface actions we may do away with the customary baths, as the cleaning of the body can be instantaneously effected simply by connecting it to a source of currents or electric energy of very high potential, which results in the throwing off of dust or any small particles adhering to the skin. Such a dry bath, besides being convenient and time-saving, would also be a beneficial therapeutic influence. New electric devices for use of the deaf and blind are coming and will be a blessing to the afflicted. In the prevention of crime, electrical instruments will soon become an important factor. In court proceedings, electric evidence will often be decisive. In a time not distant, it will be possible to flash any image formed in thought on a screen and render it visible at any place desired. The perfection of this means of reading thought will create a revolution for the better in all our social relations. Unfortunately, it is true that cunning lawbreakers will avail themselves of such advantages to further their nefarious business. Telegraphic photography and other advances, great improvements, are still possible in telegraphy and telephone. The use of a new receiving device, which will be shortly described, and the sensitiveness of which can be increased almost without limit, will enable telephoning through aerial lines or cables, however long, by reducing the necessary working current to an infinitesimal value. This invention will dispense with the necessity of resorting to expensive constructions, which, however, are of circumscribed usefulness. It will also enormously extend the wireless transmission of intelligence in all its departments. The next art to be inaugurated is that of picture transmission by ordinary telegraphic methods and existing apparatus. This idea of telegraphing or telephoning pictures is old, but practical difficulties have hampered commercial realization. A number of improvements of great promise have been made, and there is every reason to expect that success will soon be achieved. Another valuable novelty will be a typewriter electrically operated by the human voice. This advance will fill a long-felt want, as it will do away with the operator and save a great deal of labor and time in offices. A new and extremely simple electric tachometer is being prepared for the market, and it is expected that it will prove useful in power plants and central stations, on boats, locomotives, and automobiles. Many municipal improvements based on the use of electricity are about to be introduced. We have soon to have everywhere smoke annihilators, dust absorbers, ozonizers, sterilizers of water, air, food, and clothing, and accident preventers on streets, elevated roads, and in subways. It will become next to impossible to contract disease germs or get hurt in the city, and country folk will got to town to rest and get well. Electric inventions in war. The present international conflict is a powerful stimulus to invention of devices and implements of warfare. An electric gun will soon be brought out. The wonder is that it was not produced long ago. Dirigibles and aeroplanes will be equipped with small electric generators of high tension, from which the deadly currents will be conveyed through the wires to the ground. Battleships and submarines will be provided with electric and magnetic feelers so delicate that the approach of any body, underwater or in darkness, will be detected. Torpedoes and floating mines are almost in sight, which will direct themselves automatically and without fail get in fatal contact with the object to be destroyed. The art of teleautomatics, or wireless control of automatic machines at a distance, will play a very important part in future wars, and possibly in the next phases of the present one. Such contrivances which act as if endowed with intelligence will be used in innumerable ways for attack as well as defense. They may take the shape of aeroplanes, balloons, automobiles, surface, or underwater boats, or any other form according to the requirement in each special case, and will be of greater range and destructiveness than the implements now employed. I believe that the teleautomatic aerial torpedo will make the large siege gun, on which so much dependence is placed at present, obsolete. A volume might be filled with such suggestions without exhausting the possibilities. The advance even under the conditions existing is rapid enough, but when the wireless transmission of energy for general use becomes a practical fact, the human progress will assume the character of a hurricane. So, all-surpassing is the importance of this marvelous art to the future existence and welfare of the human race, that every enlightened person should have a clear idea of the chief factors bearing on its development. The power of the future we have at our disposal three main sources of life-sustaining energy: fuel, water power, and the heat of the sun's rays. Engineers often speak of harnessing the tides, but the discouraging truth is that the tide water over 1 acre of ground will, on the average, develop only 1 horsepower. Thousands of mechanics and inventors have spent their best efforts in trying to perfect wave motors, not realizing that the power so obtained could never compete with that derived from other sources. The force of wind offers much better chances and is valuable in special instances, but is by far inadequate. Moreover, the tides, waves, and winds furnish only periodic and often uncertain power and necessitate the employment of large and expensive storage plants. Of course, there are other possibilities, but they are remote, and we must depend on the first of 3 resources. If we use fuel to get our power, we are living on our capital and exhausting it rapidly. This method is barbarous and wantonly wasteful, and will have to be stopped in the interest of coming generations. The heat of the sun's rays represents an immense amount of energy, vastly in excess of water power. The Earth receives an equivalent of 83 foot-pounds per second for each square foot on which the rays fall perpendicularly. From simple geometrical rules applying to a spherical L body, it follows that the mean rate per square foot of the Earth's surface is 1/4 of that, or 23/4 foot-pounds. This is to say over 1 million horsepower per square mile, or 250 times the water power for the same area. But that is only true in theory. The practical facts put this in a different aspect. Considering the United States, and taking into account the mean latitude, the daily variation, the diurnal changes, the seasonal variations, and casual changes, this power of the sun's rays reduces to about 1/10, or 100 horsepower per square mile, of which we might be able to recover in high-speed, low-pressure turbines 10 horsepower. To do this would mean the installment of apparatus and storage plants so large and expensive that such a project is beyond the pale of the practical. The inevitable conclusion is that water power is by far our most valuable resource. On this, humanity must build its hopes for the future, with its full development and a perfect system of wireless transmission of the energy to any distance. Man will be able to solve all the problems of material existence. Distance, which is the chief impediment to human progress, will be completely annihilated in thought, word, and action. Humanity will be united, wars will be made impossible, and peace will reign supreme.